you. Yeah, suppose I'm audible to you.
So,
How are you?
um,
Yes, I'm also good. Fatima, I think you were absent in the previous classes.
I was
Fatima.
absent. I was
Mhm.
absent on day.
Okay, Fatima, please speak a little bit louder. We were doing this chapter heat. Did you attended any classes of this chapter, or is this your first class for this chapter?
So it is the first class.
This is the first class for you. Okay, see, there have already been around one class in this chapter, two classes, I would say. Okay, so meanwhile, others, Yuan, let me quickly revise the concepts which we have learned so far. Okay, now, see, in the chapter heat, before we continue this, do tell me which chapter is currently going on in your school?
So it's acid, base, and salts.
Okay, the chapter right after this, that chapter is going on. Okay, and regarding your exams, upcoming exams, is there any upcoming exam in your school?
So,
Not yet. Okay, whenever there is, do let me know. So in this chapter heat, we learned about following things. First of all, we're going to learn about what is heat. Basically, we see that heat is a form of energy that makes substances hotter, and it's a form of energy that makes substances hotter. Although it can't be seen by us, but we can feel the effect of heat. We can feel the heat. Although we can't see it, but we can feel the effect of heat when it is produced. So when heat is given to a substance, we find that its temperature increases and thereby it becomes hotter. Say for example, when a utensil is kept on a gas burner, it gets heated and its temperature increases and thereby it becomes hot. Or on the other hand, say heat is removed from a substance. Say that you keep a substance in the refrigerator, so thereby its temperature decreases and it becomes cold. Just like water, when it is kept in a refrigerator, thereby what happens? Heat gets removed from water, its temperature decreases and it becomes cold. That's what happens usually. So in our daily life, we come across a number of objects. Some of these objects are hot, some of these objects are cold. Yeah, Sullivan, Assalamu alaikum, how are you? By the way, both of you are required to turn your cameras on in the class. Okay, no? Both of you are required to turn your cameras on in
sir,
the
I will
class.
just go take my notebook. Then when I come back, I'll turn on my video.
Okay, okay. See, this has been notified from the team that you guys are required to turn your cameras on in the class. Okay, no? So thereby it becomes important. Also, your parents would be notified, like they would be notifying your parents if you don't turn your cameras on regularly in the class. Okay. So Fatima, so far we were learning that heat is a form of energy actually. How do we practically how do we get to observe this? See, whenever you touch a hotter object or whenever you touch a colder object, whenever a hot object or a cold object comes in contact with each other, we say some type of energy is flowing from the hot object to the cold object, right? Say for example, you are holding some ice cubes in your hand, so thereby heat, your hand is hotter than the ice cubes, so heat flows from your hand to the ice cube. So this is some energy that is flowing from your hand to the ice cube, so that energy is called as heat energy. This energy is called as heat energy, and the SI unit of heat is joule. It is measured in joule. Earlier, it was measured in calorie. Is that clear so far? Yes, Fatima.
Yes, sir.
Furthermore, there was this question that can we always rely upon sense in order to say whether a given substance is hot or whether it is cold? So obviously in most of the cases you can just by touching you can say whether the object is hot or cold, right now Suleiman and Fatima. But sometimes our sense of touch is not reliable in telling us whether an object is really hot or cold. This will become more clear while we discuss this activity. Suleiman, you back in the class?
Yes, sir.
Okay. Okay, just we'll be taking 5 minutes to quickly revise these concepts, guys. Then we will continue. Okay, na Suleiman? Since Fatima has joined,
Yes, sir.
didn't join the previous class, so just let us quickly revise this. So, Fatima, what we have done over here, we have taken three balls, namely A, B, and C, and put some water in them. In bowl A, you have put some cold water. In bowl B, you have put some warm water, and in this, you have put some neutral water, neither warm, neither cold. Okay, no? So when you dip your hand in the cold water in bowl A, so thereby your right hand, this your hand, it will feel cold. When you put it in the warm water, obviously it is going to feel warm. But when you dip your hand in this normal water, then an interesting thing happens. Say for example, the temperature of your hand is 37 degrees Celsius and that of this cold water is 5 degrees Celsius. So heat will flow from your hand towards the water because it is the property of heat that it always flows from a hotter body towards the colder body. In bowl B, what will happen now, Fatima and Suleiman? Which one is hotter? Obviously, water. Say the water temperature is 45 degrees Celsius and that of your hand is 37 degrees Celsius. Then, Suleiman, what will happen in bowl B?
Sir, the temperature of the hand will become hot.
It will become hotter, but where will be the heat flowing? Your
Sir,
hand will
from the top to the hand.
from the water to the hand, no?
Yes.
Because water is 45 degrees Celsius while your hand is only 37. Getting it, Fatima? So from higher temperature towards lower temperature, heat will be flowing. Now, what happens in case C, in bowl C? Now, this hand A, you have dipped into this. So your hand was cooler now. Say what happened. Some Your hand lost some heat in bowl A. So thereby it become colder, and let's say that your hand become cold to 14 or 15 degrees Celsius. Let's say it became colder to 15 degrees Celsius. Earlier it was 37, now it became 15 degrees Celsius. So thereby also take this thing that the temperature of this normal water is 25 degrees Celsius. So now look at your hand A and the temperature of this normal water. This is 25 degrees Celsius, your hand is 15 degrees Celsius. Fatima, you answer to me. Where will be the heat flowing from? Will it be flowing from the from the water towards your hand or from your hand towards the water?
Sir, from the hand towards the water.
From the
Water.
from the water to the hand?
Yes.
Okay, na? Why is
Yes.
that so? Why does that happen? What's
Because
Suleiman, you would
because
like to answer? Yes, Fatima?
because the temperature of hot and cold water mixes and makes the heat come out.
See, the simple reason is that Suleiman, you would like to answer this?
Sir, the touch C one.
Yeah.
Huh?
Yes, you have to answer.
Yes, sir.
Why heat will flow from the water to your hand in your hand A?
Sir, hand A is 15 degrees and hand B is 40 degrees.
No, right now we are only talking about your hand A now. Hand A,
Yes.
look at the temperature of hand A, it's 15 degrees Celsius. Water,
Yes.
normal water temperature, let's say 25 degrees Celsius. So your hand feels warmer in when you dip it into this normal water, your hand A will feel warmer because heat is flowing from a high temperature towards a lesser temperature. The temperature of water is 25. The temperature of your hand is 15 degrees Celsius. So heat will flow from the higher temperature to a body having lesser temperature. That is the main reason, no?
Yes, sir.
Okay. Now you guys explain why your hand B is going to feel colder. The temperature, say it's 40 degrees Celsius. Huh? After you dip your hand B into warm water, no? So thereby your temperature increased to 40 degrees Celsius. Why it is going to feel colder in bowl C? Earlier it was feeling warmer in this water, but in normal water, this hand will be feeling warmer. Fatima, are you getting this concept or not? Please tell me.
It's a bit confusing. I'm not getting it.
A bit confusing. Okay. See, remember this golden rule that heat flows from a hotter body to a colder body. Or otherwise, we can say that heat flows from a body at high temperature to a body at low temperature. So these two statements, you guys can clearly understand what it means to say. Hmm? Say you have two bodies, body A and this is body B. Both of them are in contact with each other. So body A, its temperature is 45 degrees Celsius. The body B, its temperature is 30 degrees Celsius. Do tell me, will the direction of heat flow be this or will it be this? A or B? The heat will flow from a hotter body towards the colder body now, from A to B, isn't it? Fatima and Suleiman, is that
Yes.
thing clear? It will flow from a body having high temperature to a body having colder temperature, lesser temperature. Understood that thing now? So do tell me, body A is losing some heat and body B is gaining some heat. Body A, let's say that after 2 minutes, what will happen? Body B will become, let us say, it will become 35 and it will become 40. So body A is losing some heat now as its temperature decreases, and body B is gaining some heat as its temperature is going to increase from 38 increase to 35. Is it clear? Suleiman, are you not listening?
Friends,
Hmm? Are you getting it? Fatima?
yes.
Yes.
Huh. Then, having understood that, this will become easier. We are trying to do an activity, and this activity basically concludes that our sense is not a reliable method way to tell us whether an object is really hot or whether it is cold. Usually, just by touching things, by just by touching objects, you can decide whether it is hot or cold. Provided that it is not very hot or very cold. But if it's normally hot or normal cold, then you can just by touching say it. But sometimes your sense will deceive you. It's not a very reliable method. You have dipped your hand in cold water, but when you dipped it into the warm normal water, then it felt warmer. Yeah. But is the water warm in bowl C? Hello. Is the
Yes.
water is the water warm in bowl C?
Sir, it's normal temperature because there's also cold water, right?
Exactly. It's normal temperature. But what is happening in bowl A? You have here you have dipped your hand in cold water, thereby it felt cold. But when you dipped your hand in the normal water, then you will be feeling warmer. Why does that happen? The water is not warm, but your hand feels warmer. The reason being of temperature difference. Now understand it carefully. Pay all your attention here. The normal body temperature is 37 degrees Celsius. See, the temperature of hand is 37 degrees Celsius, and that of this water is 5 degrees Celsius. So there's a difference of temperature now, right? So this is warmer, this is colder. Heat flows from warmer body to a colder body. So some of the heat will be lost into it. So let's say now your hand has the temperature at 15 degrees Celsius. Its temperature decreases, let's say. Although after some time it will get back to normal due to blood circulation. Then once you dipped into the bowl C, in which normal you have taken normal water. Previously, the temperature of your hand decreased to 15 degrees Celsius because of putting it in the cold water. And know that the temperature of normal water is 25. Now here the water is the warmer body now. Your hand is the colder object now. So now heat will be flowing from this warmer body, that is water, to your hand. That's why you will feel warm in bowl C. Is that clear to everyone?
Yes.
Yes.
Same thing you can understand in a similar manner about this hand B. You put in the bowl B. So see, the temperature of water is 45 degrees Celsius. Although it is not recommended to put your hand in a warm water having temperature this much. So say it is 45 degrees Celsius and your body temperature is 37 degrees Celsius. So once you put it, so thereby the heat will flow from the water towards your hand, because the water temperature is 45 and that of your hand is 37. There's a difference of temperature. This is warmer, this is colder. So heat flows from the water to your hand. And let's say the temperature of your hand increased to 40 degrees Celsius. Now, once you put it in the normal water, then compare the temperature of your hand and that of this water, which is the warmer object now. Yeah, Fatima, Suleiman. Now, which is the warmer object? Obviously, your hand now.
Yes.
Yeah. So from your hand, it will flow into the water. So you'd be losing heat. So thereby, this hand will feel colder. This hand feels colder, and this feels warm. Understood the concept or not?
Yes.
Very good. So your sense of touch is not always a reliable method. So thereby you'd be using a thermometer, which you'd be learning in a minute, right now. So we have different hot and cold objects. Just by touch, you can see for most of them, but it is many times misinforming us. Like in this case, it is misinforming us. So a reliable measure of hotness or coldness of an object is its temperature. How hot or how cold an object is, it is temperature. So it is the degree of hotness or coldness of an object that will be measured using a device called a thermometer. It's a device that can be used to find how hot an object is. And there are different units to measure temperature. This thermometer which is going to be of different types, like we'd be having a clinical thermometer, laboratory, and a minimum and maximum thermometer. Different types of thermometers are there as per their use. And just like you measure weight in kilogram, pound, etc., so heat will also be measured in different units like Celsius, Fahrenheit, and Kelvin. Then previously we learned about a clinical thermometer, also called as a doctor's thermometer or a medical thermometer. Suleiman, tell us what are the properties of clinical thermometer?
Uh,
What are the things we learned about clinical thermometer?
Sir,
What?
sir, sir, clinical thermometer is used to measure the temperature of objects. Its ranges from
No, not temperature of objects. No.
temperature of body.
Yeah.
And its ranges from 11 degrees, right?
What are you saying? Can ever the temperature of human body go down to 11 degrees Celsius?
No.
The human be alive at that
Sir, from
temperature, huh?
37 to 42.
No, that is wrong. 35 to 42. 35 to 42. Let us quickly recall this concept. See, Fatima, you also pay attention here. Clinical thermometer, also called as doctor's thermometer, is used to measure the temperature of the body, temperature particularly of the human body. So it will be commonly used as clinics. So thereby it is also called as clinical thermometer. It is having a glass body and there's a narrow tube in the middle of it. That is also called as capillary. This narrow tube ends at this bulb, and this bulb contains a liquid metal called as mercury. So it's the property of mercury that whenever it is heated, it will expand. This mercury that you see over here in the silver color, as you can see, whitish silver color, it will expand whenever it comes in contact with heat. So it is filled into this bulb, and whenever it is put into the mouth of the patient or in the underarm, thereby due to heat, the mercury will start to expand into this capillary, into this thin tube. So say someone is suffering from a fever. Let us say the temperature is 38 degrees Celsius. So mercury will start to expand, and here it will stop at 38. Say that someone is not suffering from fever. So the normal body temperature will be 37. So as you put it in the mouth of the person, it will expand, and it will stop at 37. So that is how it basically works. Okay. Then further, you can see that there's a constriction in the capillary in this tube. This constriction is there because as soon as you take the clinical thermometer out of the mouth of the person, then mercury will start to fall back towards the bulb because it is no longer in contact with heat. No longer in contact with heat. So therefore, mercury will start to fall back towards the bulb. So in order to delay the fall back of mercury, stop it from immediately falling back towards the bulb. So thereby you have a constriction called as kink. Is that much clear?
Sir, can mercury break?
Can mercury break?
Yeah.
No, not like a metal or not like other things. It can't break, but you can simply split into different pieces. Right now, like you
Sir,
can separate it, and it will be in spherical shape. Yeah.
sir, there's a substance like this one in image that can break any metallic things.
Complete your question. Your question seems to be incomplete.
There's a substance like this, the metal one in the image we can see. Is it the one that helps to break the mercury?
No, this is mercury simply. This is simply mercury. This substance over here is simply mercury. Okay, now the mercury that is filled into this bulb. It's the same mercury that is used in compact fluorescent lamps also. Over here, you see this person that is holding this
Sir,
mercury.
if we drop this on like a example like a MacBook, I heard it will take like paper.
It will take.
It will like tear like paper.
No, it will not tear like paper. If you drop mercury, it will kind of float like a drop of uh, what would you say? Like if you accidentally drop it, like if the mercury of the clinical thermometer, let's say if it breaks, so this will simply basically in a kind of start to float, and it can become into bubbles like this. Kind of not bubbles, I would say. It will basically, it can separate into small drops like this. If you take it in your hand, it will simply kind of float. If you take mercury in your hand, it will simply float.
Sir, will it burn?
No, it will not burn. Neither will it stick. It is not sticky. Mercury is non-sticky. Unlike water, water is sticky. Now, water will stick to your hand. But if you hold mercury in your hand, it will kind of float without sticking to your hand. Hope you're getting try to visualize it. It will kind of float in your hand, not stick to your hand. Also, it is very toxic. It can lead to death. Okay, now earlier it was used, it was called as quicksilver. Not earlier, I mean to say historically it has been called as quicksilver. Right now, shows because it kind of it has a color similar to that of silver. So earlier mercury was called as quicksilver. because the thing is that it represents a color like silver, and it is very quick meaning that its molecules are at higher motion, its molecules keeps on moving continuously. So if you were to drop this mercury somewhere, it will keep on flowing unless you stop it. If you take, let us say, if you take mercury in a beaker and if you drop it on the floor, you know what will happen? It will continue to flow, and unless something obstructs its flow, it will keep on flowing. Getting it, guys? So that's why it is quick and silver, because it has a color similar to that of silver. So it historically it has been called as quicksilver also. Quick here because of its mobility, because of its movement. Is that clear? Is that much clear?
Yes, sir.
Apart from using it in clinical thermometer, that is used in compact fluorescent lamps also. Although compact fluorescent lamps are not manufactured nowadays. So that is clinical thermometer, and there are some precautions you need to take care of while you are taking reading using a clinical thermometer. Like while you're taking the reading, first of all, make sure that reading of the clinical thermometer is at 35 or below 35. At 35 or below 35. So that is one of the first precaution that you need to take care of. Right now, and also in this, you can clearly observe that it has a range of 35 to 42 degrees Celsius, because the human body temperature lies in this range only, in between 35 and 42. Okay. So clinical thermometer, while using it, should be first of all washed before you are going to use it. First of all, wash it with an antiseptic solution. Before using the clinical thermometer, you should ensure that the mercury level in the tube is at 35, is below 35 degrees Celsius mark. It should be up to here only, because if it is more than that, then you will get an incorrect reading. Further, you should keep it along the line of your sight like this, right in front of your eyes, in order to read this. Clinical thermometer should never be touched with its bulb, because that will give you incorrect reading. Okay, it should be handled with care, because it can break since it is made up of glass. So because of all these problems and all of these precautions which we have to take care of, thereby we invented this digital thermometer. So digital thermometer has so many advantages as compared to the clinical thermometer. So digital thermometer works using a thermistor. See, thermistor, it's basically an electronic device which is fitted at one end of this digital thermometer, and upon coming in heat, it will become active, and it converts those message into the digital form, and it is displayed on this displaying unit. So nowadays digital thermometers are being used to measure the body temperature. It's a safer device because here neither mercury is being used, neither it is breakable. Okay, neither mercury is used, neither it is breakable. So mercury being a toxic substance, many times if someone were to accidentally, if it goes into the food or some child eats that, it will be very problematic. Today we'll be learning about this laboratory thermometer. What is laboratory thermometer? How does it work? All those things we are going to discuss about it. By the name itself, one thing is very clear, that this laboratory thermometer is used for measuring the temperatures in a science laboratory. So it is made up of a long glass tube, and it has a very thin capillary. The capillary is very thin. The range of a laboratory thermometer is from minus 10 degrees Celsius to 110 degrees Celsius, because obviously the reactions that you carry out in the laboratory can be highly exothermic, can give lots of heat, and can be reactions. The temperature of the liquid can go down up to minus 10 degrees Celsius. So range of laboratory thermometer is generally very high, from minus 10 to 110 degrees Celsius. Furthermore, you need to understand how we are going to use it and how it is used. Before that, there's a special feature about this. There was a feature called as kink, which was found in the clinical thermometer, isn't it? Kink was present there now, but here it is absent. Okay, it is not found in the laboratory thermometer. So you would be dipping this laboratory thermometer vertically into the solution. The solution, say you have taken a water here. This person is able to directly hold it using his finger, and he is taking the reading. So the mercury in this tube will expand, and wherever it stops, that will give you the reading of the temperature of water. Say if it was another liquid which would be giving, which would be very hot, so thereby you will need a holder in order to hold this. Also, if you take it out from this beaker, as you take out this laboratory thermometer from the beaker, then what will happen? The mercury will start to fall back towards the bulb. So hence your reading will be wrong. So you have to take the reading while it is still dipped into the beaker, into the solution. Is that clear to everyone?
Yes.
So laboratory thermometer, it should be held vertically above the liquid of which you want to take temperature. It should not be tilted. It should not be tilted like this. Don't hold it like this. That would be wrong. Furthermore, the thermometer bulb should be surrounded from all sides by the substance whose temperature is to be measured. So it has to be basically dipped into this properly. Getting it, guys? So while it is still in touch with the substance, at that time you have to take its reading. It's not like you would take this out and then take reading. Okay, no? And do not hold the thermometer by the bulb. Obviously, you won't be holding this part. You'll be holding the opposite part either by a hand, by your hand, or by a holder. And handle it with care, because if it is hit against a hard surface, against a hard object, it might break. Okay. So now you guys tell me. There's a question regarding this. Can we use laboratory thermometer to measure human body temperature? Yes, Fatima and Suleiman, can we use laboratory thermometer to measure human body temperature?
Sir, no.
So
No. Okay, that is correct. But why? Why is that so?
Sir, the reading will be wrong.
The reading will be wrong. Okay. See, basically, the thing is that as soon as you will be taking it out, reading will be wrong correctly. Correct, that is correct. As soon as you take out, as soon as you will take out the laboratory thermometer from the mouth of the person, the level of mercury in it will, in the tube, will start to fall back very quickly. Right now, because the bulb, this bulb will, due to this bulb will start to cool down. As long as you kept this laboratory thermometer in your mouth, the bulb was in contact with heat now. As soon as you take it out, so thereby now the bulb is in contact with air. So due to air, it will cool down. This bulb will cool down due to air. So thereby the reading will be wrong. Getting it, guys? So clinical thermometer will be used instead of this to measure the body temperature. Right? And one should keep a clinical thermometer or a digital thermometer at a home. Okay, na? So hope that is clear to everyone. So clinical thermometer should be used. Then you have other types of thermometers also, like you have minimum and maximum thermometer. So minimum and maximum thermometers are the kind of thermometers, like it would be telling you the maximum temperature of the day. Usually, the maximum temperature of the day reaches in the afternoon, while the minimum temperature of the day usually occurs in the early morning, isn't it, guys? So, in weather forecasting, you would have seen a weather report like this would be published. If you happen to read newspapers or watch or see the weather forecastings nowadays, weather forecast updates are available on your smartphones as well. So there you would be having the temperature, what would be the temperature throughout the day, what would be humidity, what would be the direction of flow of wind, at what speed the wind will be flowing, what are the chances of rainfall. All those things are displayed in a weather report. So information like what was the minimum temperature throughout the day, what is the projected maximum temperature during that day, what would be the humidity, what is the likelihood of rainfall occurring on that day, what is the direction of wind flowing, will there be a storm, huh? All those things are displayed in a weather report. Out of the different temperatures, you guys tell me what was the minimum temperature during that day. Observe it.
Sir, 3 a.m. The second one.
um,
21 degrees.
21 degrees Celsius now.
Yes.
3 a.m. that is early in the morning. At 6 a.m. also. So early in the morning, the temperature is very low. You will have observed this obviously when you go for a morning walk. The temperature at that time is usually low. What was the maximum temperature?
So 27 degrees.
27 degrees Celsius, right? So we are able to the meteorologists who are into the work of publishing weather reports, they're called as meteorologists. So in weather forecasting, weather forecasters and meteorologists, they would be using a maximum and minimum thermometer like this. Okay, now. So the maximum, basically the thing is this spatial thermometer, maximum minimum thermometer, it will automatically record the maximum and minimum temperature of the day. So the
Sir,
maximum and minimum temperature of the previous day reported in weather reports, televisions, and newspapers are measured by the maximum and minimum thermometer.
sir,
So
but will it
this,
show?
yes,
Sir, but will it show when it rains?
will it show in?
When it rains,
Complete your question again, please.
will this thermometer show like when it will rain?
When it will rain, yeah. At that time also it will work. But one important thing about this maximum and minimum thermometer is that it will tell you the temperature of a day before. It will tell, like, say, for example, when weather reports will be published in the televisions and newspapers the next day. So this, using this maximum minimum thermometer, it will tell you the maximum and minimum temperature of the previous day. Right now, like right now, say that right now it won't be able to tell me what the temperature of today is going to be. It will be able to tell you the temperature of previous day only. Say for example, you are using this on Monday. So on Monday, you'd be having the previous temperature of Sunday only using this maximum and minimum thermometer. So it tells the temperature of the previous day. What was the minimum and maximum temperature of the previous day? Is that clear to everyone? So it is designed to record both the maximum and minimum temperature that have occurred over a given time period. Nowadays, you have more advanced versions of maximum and minimum thermometer in the market. Okay. So hope that is clear to everyone. So we learned about 3 types of thermometers. Okay, now. So let us do some questions on different types of thermometers. So let us do that. Okay, first question would be, you guys tell me, why do we use mercury in clinical and laboratory thermometer? Yes. Why do we use mercury? It's a simple question.
To know the temperature.
To measure temperature, but that is not the
To know
main
the
answer,
degree.
exact answer. To
To know
measure?
the to measure the degree.
No. Instead, see, in place of mercury, we could have used iron. We could have used any other things. But why aren't we using any other metal? Why we use only mercury?
Sir, because mercury is the only metal which can be
Hmm.
in liquid form.
Which
Yes,
exists
sir.
in the liquid state. That is correct. Also, mercury expands in a uniform manner. Previously, also I told you, Suleiman, about this. Like mercury, Fatima, you also pay attention here. Mercury. The thing about mercury is that it expands at a uniform state, a uniform manner. It's not like one time you took the temperature of the body, it was 37. 5 minutes later, you took the temperature of the body, it became 40. 5 minutes later, the temperature became 35. No, if you if your body temperature is not varying, in reality, if it is not varying, so every time it is going to show the same temperature. Every time it would be showing the same temperature. Let's say the second time also it will be showing the same temperature. Third time also same temperature. Because the thing is that every time the mercury will be put in your mouth, it will expand in a uniform manner. It will expand, and will stop at 37. You put it in your mouth after 5 minutes, then again it will expand, and stop at 37. So if you are not suffering from fever, so no matter how many times you take the reading using this clinical thermometer in which mercury is filled, every time you'd be getting a temperature around 37 degrees Celsius. So it's a liquid metal. That's why we use it. That is correct. Furthermore, is that at low temperature, it will is even at a temperature of 35, 37, 35 or 37 is not a very high temperature. Huh? Like if you were to heat iron or anything to 35 or 37, it will not melt, it will not expand, nothing like that happens. But since it's a liquid metal, so at a low temperature like 35, 37, it starts to expand, and every time it will expand in a uniform manner. How is that proved? Because you'd be getting the same reading. Is that clear to everyone?
Yes, sir.
Okay, no? Okay, so there are some questions we are going to be solving now. Answer these questions in the chat box, guys. I'm marking them as 1, 2, and 3. You know where you have to answer. On this ID you have to answer. Okay. Very good, Suleiman. That is correct. Yeah, Fatima, for the first one, your answer is correct. That is degree Celsius. The spelling is also wrong. Anyways. And for the third one, it is 37 degrees Celsius. Very good.
It was in autocorrect. That's why the spelling was wrong.
Okay, no issues, no issues. Answer these questions also. Just write the option number. Like question number 4, it's if the answer is option E, let's say if there were to be option E, just like write answer in this manner. No need to type the whole sentence or word. Yes, guys, you have to answer these ones also. The maximum and minimum temperature of a day are measured with a. Okay, Sullivan, let me check. That is first one is correct. Second one is also correct. Third one also it is correct. Very good, Sullivan. Yes, Fatima, waiting for your answer. In a digital thermometer, we use an electronic device. What is the name of that electronic device used in a digital thermometer? Okay, Fatima, you answered the question number 6. That is true. No need to write the whole option. No need to type the whole option. Just write the options like A, B, C, D, whatever the answer is, like that. We have to save our time. Yeah, Suleiman, you answer this question. What is the name of that electronic device used in thermometers? It is used in other devices like um, in air conditioners also. Remember? They have a digital thermometer like this. Um Remember, we talked about this. It is thermistor now.
Yes.
Note it down in your copy. You'll again forget it if you don't revise it. Fatima, you're done. You have an answer question number 4 and 5. Maximum and minimum temperature of a day are measured with a maximum minimum thermometer simply. Liquid metal used in a thermometer is mercury. And the answer for this one is option A. Okay. Okay, we have few more questions.
So my answer for the mercury was right.
Which one?
So the second one, the liquid metal used in a thermometer is mercury.
Yeah, exactly. That is mercury. Okay. And for the question number 4, that is maximum and minimum thermometer. Okay, guys, answer this question also. Try to answer it quickly. While answering, write the question number also, like question number 7 if it's E, question number 8 if it's F, like that. So, Fatima, you have answer for question number 7, right?
Yes,
Okay, question.
the first
Okay,
one.
okay. That is not correct actually. That isn't correct. Suleiman, the answer for the first one, you have also done it wrong. You have also answered it wrong.
Sir,
This,
you didn't explain the conductor part, right?
okay, we haven't learned that, but you can see it's an extra question, but I believe that you should know about this one also. Like conductor basically is what? Okay,
Sir,
I'm defining
conductor,
it. Okay, define it.
sir, a metal which lets heat pass through.
not just a metal. Basically, usually all the conductors are metals. We say that any substance that allows the heat to pass through it, which conducts the heat, that is called as a conductor. Iron, steel, aluminum, all of them are metals. All of them are good conductors of heat now. So conductors are those objects that conducts the heat, that allows the heat to pass through it. Meaning that if you were to hold a piece of iron rod over a flame, thereby after 5 minutes or so, you observe that the other end also becomes hot. So whether this is made up of iron or steel or aluminum, in all the cases, other end also becomes hot. But at the same time, you guys tell me, if you were to held a piece of wood, say you have taken a piece of wood, so will it happen that the other end of the wood will also become warm? Have you ever tried holding a piece of stick into the fire?
No, sir.
That does not happen, no. The reason is that because it does not allow the heat to pass to the other end. It does not allow the heat to pass to the other end. Does not allow the heat to conduct through it. So that is a insulator. That is a bad conductor of heat, which we call as insulator, which does not allow heat to pass from one place to another. Okay, now let us continue with the question then. So what would be the answer now for the first question? All of these now? All of these are conductors, okay. Which of the following thermometer has a king? Yeah, both of them. Very good. Both of you have answered it correctly. Question number 9. Have you guys answered this? Fatima, you have answered for question number 9.
Yes, sir.
Yeah, that is correct. Good. Habib, you have also answered it, but you have answered it incorrect. Read the question once again. It's talking about a clinical thermometer, but you have answered for a, if it was a laboratory thermometer, then it would be minus 10 degrees Celsius to 110 degrees Celsius. Okay, Suleiman. So that is option number A, not B. All right, now. Okay, answer these questions quickly. Answer in the class only. Which of the following thermometer contains mercury? Yes, Fatima and Suleiman.
Sir, clinical thermometer.
Hmm.
Sir, can you hear me?
Yes, you're audible.
Is it clinical
Sir, is it
thermometer?
C option?
It's
Yeah.
both now.
Yeah. Sorry.
Yeah, no worries. So both of them contains mercury. Option C is the correct one. Then laboratory thermometer. Just now I told you that it is
Sir, 10, 10, 10 and 110 Celsius.
minus 10 degrees Celsius to
Yes.
110 degrees Celsius. Okay, na?
Yes.
Option A and D are same, by the way. There's a mistake in this. It could be just plus 10 degrees Celsius. The materials which allow the heat to pass through them easily, what do we call them as? Last question.
Sir, is it poor conductor?
No, they
Insulator.
allow heat to pass through them. No,
Insulator.
insulators do not allow heat to pass through them. Insulator, like a wood, is an insulator. It does not allow heat to pass through it. So thereby the other end of the wood does not become hot unless the fire reaches to that end. Moments ago, we learned about steel, iron, aluminum. They allow heat to pass through them and become warm. So they are conductors now. Getting it now, guys? They are conductors. Okay, we'll be learning about it in the next class also. While the first part of the chapter that is about the different thermometers that is finished. There's this temperature scale also. We'll be learning about it also. In the next class, we'll be learning about the temperature scale, and we would be learning about good and poor conductors in the next class, by the way. Right now, we'll be having examples of different conductors of heat, insulators of heat, how heat will be transferring from one body, one object to another. All those in the next class. So that's it for today. We'll be meeting in next class then. Allah Hafiz.
Officer.
Allah Hafiz.